Hello, everyone, and welcome to St. Andrew's Institute of Technology and Management, Gurgaon, Delhi, NCR. St. Andrew's Institute of Technology and Management is the best college in Delhi, NCR, in northern India, and it is the fastest growing college in entire India. We offer a variety of courses from BTech, BCA, BBA, and soon starting with MBA, LLB, and architecture. St. Andrews provides 100% placements of its students. St. Andrews works tirelessly for its students. It is the best college that you can get yourself admitted into. Welcome. The subject we shall be looking over here is Principles of Software Engineering. Code is CSE 302F. This is a CSE 6 semester subject. The syllabus is in accordance with MDU University Rohtak. The topic we shall be discussing here are data flow model, control flow model, the control and process specifications, and the data dictionary. Data flow model. A data flow diagram or DFD is a traditional visual representation of the information flows within a system. A neat and clear DFD can depict the right amount of system requirements graphically. It can be manual, automated, or a combination of both. Right? So, we also previously discussed DFDs into when we did our functional modeling. Right? So, this kinds of give you a visual representation and they are gives a structured analysis. Right? So, data flow diagrams helps in a proper flowing of the information, right? And it gives you the right knowledge for the system. It can be manual, automated, or a combination of both. It shows how data enters and leaves the system, what changes the information, and where data is stored. There, the following observations about DFDs are essential. Number one, all the names should be unique. So this makes it easier to refer the elements in the DFD. Like no two elements can have the same name. This should be a requirement of while drawing a DFD. Remember that DFD is not a flowchart. So arrows in a flowchart that represent the order of events, arrows in DFD represents flowing data, right? So in a flow chart, it is representing the order of the event, like sequential one, first this, then this, then this. Whereas in a DFD, it is actually showing how the information or how the data is flowing from one state to the another state. Suppress logical decisions. If we ever have to urge to draw a diamond shaped box in a DFD, suppress that urge. A diamond shaped box is used in flowcharts to represent decision points with multiple exit paths of which the only one is taken. This implies an ordering of events, which makes no sense in a DFD. Do not become bogged down with details, right? So defer error condition and error handling until the end of analysis. So any error condition and any error handling has to be postponed unless and until you reach the end of the analysis. So what we learned, that all names should be unique. The DFD, the arrows indicate the data flow. We need to suppress logical decisions and we cannot throw diamond boxes. And we should not be writing too much detail about error and all. Okay. Now the following symbols are used in a DFD. So the first is a circle or bubble. This shows a process that transforms data inputs into data outputs. Data flow. A curved line shows the flow of data into or out of a process or data store. Data store. A set of parallel lines shows a place for the collection of data items. So a data store indicates that the data is stored which can be used at a later stage or by other processes in a different order, right? So any data store can be used by any process in any order. Okay, so the data store can have an element or group of elements. Source or sink. The source or sink is an external entity and acts as a source of system inputs or sink of system outputs, right? So there are following levels. There are 0, 1 and 2 in a DFD and we study them one by one. So first is 0 level DFDM. It is also known as fundamental system model or context diagram. Represents the entire software requirements as a single bubble with input and output data denoted by incoming and outgoing arrow. So herein we will represent a single bubble with inputs and output data, and they will have incoming and outgoing arrows. So then the system is decomposed and described as a DFD with multiple bubbles. So what will the system will do? It will get decomposed and it will be described as a DFD with multiple bubbles. Parts of the system represented by each of these bubbles are then decomposed and documented as more and more details DFD. So after making the initial one with an input and output and the incoming and outgoing arrows, we further starts decomposing it, right? And keep on adding more details to our DFD. So starting from the uniques to one system, it is actually being again and again divided into subsystems. And this process may be repeated at as many levels as necessary until the program at hand is well understood. Right? Now we come to one level data flow diagrams. In one level DFD, a context diagram is decomposed into multiple bubbles or processes. In this level, we highlight the main objectives of the systems, right? So there will be multiple bubbles and they will be highlighting the main objectives of the system individually and looking at them. And break down the high level process of 0 level DFD into sub processes. So from one process, it will be divided into n number of processes. Then we comes to 2 level DFD. So 2 level DFD goes one process deeper into parts of one level DFD. So it will further refine the 0, 1 to 2. It can be used to project or record the specific necessary details about the system's functioning, right? So you'll see if there are any specific or there are any necessary details into the system functioning, right? So all this will happen. So initially what we did, we started with what? We started with one as a single system with an input, output and arrows, and then we went on further decomposing them. In one DFD, we highlighted the main objective and then broke the higher level 0 into sub processes. And in 2 level, what we did, we projected or recorded the necessary details about each and everyone's functioning. So this is how you just keep on adding further. So here we come and we have these three processes, two provider and consumers, and we have all these things, the purchasing departments, the sale department, department of production management and control, and production. So the central one is the department of production and control. So and there are a number of databases or data stores that we can say. So how many are there? 1 2 3 4. So there's a purchase order file. Okay, that's a database. There's a production data. Then again there's a second one also, production data. There are two kinds of production data it has. And then there's a product inventory file, right? So what we see the provider is placing the purchase order into the purchase department, and it is trying to require it from the production and management, the central department, the department of production management and control, right? And then it will be sending it back because our arrow flows are showing that it is flowing in both the directions, right? So good receives notes are there, the productivity price list advice notes, everything is getting along with this data. Then from the production, what it is doing, it is looking at the purchase order file, and similarly the purchasing department has a order receipts updates from the purchase order file. So all this is kind of interacting with each other. So this one is placing because the arrow single side, and from this way this is the purchase department has a two-way connectivity to the database. Then the production data is coming into the department of this management and control. Then there is this production department which is providing the production schedule to the central department. So it is a production schedule it is making, it is putting into the production data which is being fed into the department of production management and control, the central department, right? Then there is provider is there, okay, which is providing. Then we have consumer. So consumer is interacting to the department with the help of a sales department, right? So department of production management and control has sales schedule, and there's an invoice into the sales department. That is, the sales department provide the invoice to the customer, and there's this product availability into the product inventory file, and then you book into finished goods inventory from this department. So this entire thing is working like this, right? So this is a example of a DFD. You can do a smaller example also, which will be okay, accepted. You can do a simpler one also with, if the arrows are flowing one way kind of thing, that is also okay, like the one we did previously when we were doing our functional dependencies and stuff, that we distilled to DFD. So it is up to you, right? You draw, you explain. So whatever you explain, you have to remember where your source and sinks are, where you have to remember your processes, and you have to see your all the things that are changing it from one state to the other. So that's in the DFT. Okay, next we come to the control flow diagram. See, the name is suggesting. What is the name suggesting? Control flow diagrams. So this will tell you about the flow of control, right? So how actually the control is passing as and when your product is getting developed, right? So this is showing from where this will the information will lead into this and how it will be done. So a control flow diagram or graph is a graphical representation of control flow or computation during the execution of programs or application. So any kind of a program you execute or any application you want to designing anything, you need a control flow graph. So these flow graphs, CFGs are mostly used in static analysis as well as compiler applications. So for both the applications you can use it for static as well as compiler. So there are few characteristics of it, and what are they? See, control flow graph is process oriented. Control flow graph shows all the paths that can be traversed during a program execution, right? What is it? It is process oriented, and what it does, it is showing all the part that can be traversed during a program execution. So whatever is your program execution, you're trying to follow the path, that what this my program, what this my design is going to follow this path, and it's a directed graph, right? So similar to a DFD, it is also directed. So edges in CFG portray control flow paths, and no CFG portray basic blocks, right? So edges means the arrows will only show the control how it is flowing, right? And your basic blocks, like from one state to another, will be denoted by the basic blocks. So you'll have an entry block and you'll have an exit block. So entry block will allow the control to enter into the control flow graph, and exit flow leaves through the exit block, right? So it will enter through the entry block and it's going to exit, the control flow will exit by the exit block. So this is how it looks like. See, entering from the first vowel on the top. This is an if then else kind of control. We'll do if then else, while, do while, and for loop. This is initial programming construct you learned in your lower levels also, when you were discussing with the program C compiler and stuff you did. So how this control is flowing. See, once it enters, so the one on the top is an entry block, and the last one, the exit, is an exit block. So the topmost the information is flowing. So based on some kind of a situation might be there in it, so it will have two paths. If you follow this, the one on the left side, so you will go to this way, and the other will go this way. So this is a common notation you have done, is also like how this if else, if true then do this, else then true this, like, so this is the same. The control flow is the same. So this is how a while and do while. In a while, you will execute like when the condition is satisfied, so then it will repeat. Where in do while it will first be repeated for once, you will do it at the minimum for one amount of time, and then it will be repeated, right? Okay, this is a for loop wherein the instruction will be provided, then there will be a loop condition, so repetition, your iteration will be carried out into a fixed number of interval until and until it exists the system. So here a control flow, see, from one step one you reach to step two, and your step two has a kind of a decision, a control decision in which actually told you which way to go. If you choose say if you choose true, then you go to 3, and if you choose false, you go to step 4, and so it is similar of that sort, and from there in you reach a common state 5. After 5 it may exit, or after 3 may exit, or it may 4 may exit. So this is just a common example to show how it goes. So from 5 to 6 it is going, 6 to 7 then it is exiting. So it entered via 1 and it exited, the control flow exited via 7. Similarly, you can come from 1 to 6 directly. So this is showing, the arrows are showing the control flow, wherein the 1, 2, 3, all these bubbles are showing the what I can say, the basic blocks, right? So they'll have a basic set of the data wherein the control flow is only being provided by the arrows. Control specification. The control specification represents the behavior of the system, right? What kind of behavior the system had at the level from which it has been referenced in two different ways. The CSPEC contains a state transition diagram, that is a sequential specification of behavior. So this is a from sequence 1 to 2 to 3 to 4. This contains a state transition diagram, the state transition of which way it is flowing, right? So this control specification is going to show that. It can also contain a program activation table, that is a combinatorial specification of behavior. So it contains the state diagrams, and it may contains a table, but that it will describe the behavior, but it will not give you the any inner working about what exactly the process are like what are they having. So this control specification will tell you just the behavior of the system and not providing any inner working as to what inside is happening or what anything. So here in my 1 2, like if I come to my previous example and see, so 1 2 3 4 5, so what is happening is there is not important, but how it is happening is important, like how it is reaching stage 5, either it is being controlled by 3 or it is coming by path 4, right? So this is like how it goes by, right? Okay, so see, if we this is a very example that I'm taking. So there is a reading input, user input, and there is an acting on some sensor event, and then monitoring system state and displaying user feedback. So this is, I say, a control. So also this I can say an example of a switch. So any data or any sensor that it is coming in, so it is taking input from the reader, right, and it is acting on that input, and there is a monitoring system that is being described on it. So what decision it takes place, it might display user feedback. What kind of this inside display user feedback, maybe n number of things, display exit, display this, display that, but the inside working is not important. How it is being doing is like how the control is flowing is the one that we take care of here. See, the monitoring system status leads to the monitoring system status by invoking a monitor and control system sensor event, right? Then from if I invoke a display message and status, then this will go to acting on the sensor event. So this how the control is flowing from one basic block to the other basic block is being shown in this diagram. You can take any example if you like, any simpler example. Say if you want to take the business flow of a kind of a company business model, you can also take that thing. So any example you can give of your choice. So control flow specification, whether is you would first have to explain control flow, and then you have to go with okay, it has this table sort of a stuff which has a state transition diagram. So this is a state transition diagram that it has, and the inside working you would have to write, okay, this will not show me the inside working, right? Next we come to process specification. So the process specification, it is used to describe all flow models processes that appear at the final level of refinement. See, I have been done with all the control flow, the data flow, and this all the specification. So this process specification will be refinement in the end, like. So the context of the process specification can include narrative text, a program design language, that is a PDL, description of the process algorithm, mathematical equations, tables, diagrams or charts. So this will all be dealing with this. A program design language will be there that will tell you that what kind of equations and diagrams. You can write it in there, like say type L is equal to, so language is this, whatever language that you're following, we follow an HTML language, or we are doing with a Python, or we are doing with C sharp or C hash. So you can write it the small description language it will have. So by providing a process specification to accompany each bubble in the flow model, the software engineer creates a mini spec that can serve as a first step in the creation of the software requirement specification and as a guide for design of the software component that will implement the process, right? So this will be the first step that will be in the creation of your software requirement specification, the finer details. So it's a mini specification, we can say. Okay. Next we come to data dictionary. Now what is a data dictionary? A data dictionary is a file or a set of files that includes a database metadata. So it is about, I can say data dictionary is data about the data, right? So what kind of the description it being there, so it is describing the data, that is metadata. The data dictionary holds records about other objects in the database, such as data ownership, data relationship to other objects and other data. Right, the data dictionary is an essential component of any relational database. It is invisible to most database users. Typically, only database administrator interact with the data dictionary, right? So the only person that is interacting with the data dictionary are the database administration. This is an essential component of any relational data, because ultimately what data you are using into your system, you ultimately have to put a description to it also, right? So all the relationship and who is owning and everything will be described. Data dictionary will have full information about the data. So in general, what will be the following will be included. It will have a name of the data item, it will have aliases, there will be description or purpose of it, and there will be some related data items, or there will be a range of values will be there, and there will be a data structure or definition forms. So first we come to the name. So the name of the data item is self-explanatory. Aliases include other names by which this data item is called: DEO, data entry operator, and DRO, deputy registrar. Aliases will be there, right? So name will be there, and then there will be some aliases. So DEO is a kind of an alliance for data entry operator, and DR for deputy registrar. Description or purpose is a textual description of what the data item is used for or why it exists. So what kind of a data is being used and why it is existing will be actually described into the description or purpose box. So there will be some related data item that will capture relationship between data item. Example, total mark must always equal to internal mark plus external marks. So what will be my total marks contain? It will have internal marks and it will have an external marks. Range of values, say if I have a set exams of 100, so 0 to 100 will be my range of values that my data will be containing, that this will be in this range. Then there will be some data structure form. So data flow capture the name of processes that generate or receive the data item. If the data item is primitive, then data structure form captures the physical structures of the data item. If the data is itself a data aggregate, then data structure form capture the composition of the data item in terms of other data items, right? So what my data structure form will contain, it will contain all the names of processes that are receiving and generating them, that are primitive data, the physical structure of the data, a data aggregate, and everything will contain in the data structure forms. Say if this mathematical operators that we are using in this table, so x is equal to a plus me, this will mean x includes of data elements of a and b both. So a by b will means that either a or either b. If it is ax, so it includes optional data elements in a. So whatever optionals are being there, so only they will be included. Y and then a in bracket means it x includes of y or more occurrences of data elements. So like how many time it has being occurring, so how many it is occurring. If a, so and if x bracket a bracket close z means x includes of z or fewer occurrences of data elements. So the fewer occurrences or the one that are in z are the considered. So whatever is the one that are being, so either it will include z or it will have fewer number of data elements of a. Y bracket A Z means an include of some occurrences of data elements A which are between Y and Z. So what X will contain? So it will contain some occurrences of data elements A which are so whatever it are between Y and Z, so that number will be considered, right? So this is an example. So this is just important question. What is data flow model? Explain. Write in detail about control flow model. What so we write a short note on control for specification and process specification, and what is data dictionary. So that is all in today's lecture. Have a great day. Thank you.